All right, here we go. Today we are talking about solving equations with variables on both sides. This is actually lesson 1.3 if you wanted to look in your book for some extra ideas on how you can be successful on the test on Friday. So again, our goal is to be able to solve equations, but instead of two-step or just multi-step, the variables are on both sides. So obviously, our goal is to get variables on one side, because if we can get our variables on one side, then it will look just like what we've been doing recently. You might have a beautiful two-step equation to be able to go and be awesome. So I have a small question for you to get you thinking. So the question is, when you help bring in the groceries, what bags do you grab first and why? So turn to your partner and talk to them about how you help your parents and with what groceries. All right, let's see who was the responsible child and said that you were going to bring in like the big cases of water or soda or milk. A few of you, like 3. All right, and who were the lazy lying teenagers and chose to bring in like the eggs or the bread or the half-eaten bag of chips because you were eating them on the way home? None of you? All right. So this is what we want to do. We have our equation here, and we have our 2 variables. The variables are separated on separate sides by the equal sign. And again, I said the goal is to get it on one side. So, in the conversation about your groceries, the lighter is always the easier. And the lighter or the smallest variable is our goal that we want to move. So, let's move the smallest variable first. So, in this instance, it's obviously the 3x. So, if I want to move the 3x from the right side to the left side, I need to use an inverse operation, and that is going to be a simple subtract 3x on both sides. If I subtract 3x on both sides, then I have a wonderful 2x plus 1 is equal to 7. And if you notice, this is a wonderful 2-step equation that you can solve just like you did on your quiz yesterday. So go ahead and solve that 2-step equation for me. Again, using the exact same inverse operations as you used on the quiz. And you're going to use the same inverse operations on your test on Friday. So you obviously subtracted 1 on both sides. So what do you get? A 6. And then when you divide both sides, what is your value for x? The x is obviously a 3. So the only thing that's new is this piece right here, at least for this problem. And again, move the smallest variable first. Maybe you want to highlight that, put a star around it, or next to it, circle it, something with move the smallest variable first. And again, a nice little strategy is to check. So let's just go off to the side. And when you check it, you're taking each x. So it means the 3 is going to go for each x. And I have everything presented to you right there. So you have 5 times 3 because it's 5 times x. And then it says plus 1. 3 times 3. And then a plus 7. And again, this is why I was asking you to be able to do the comparison there in your check, the 16 equals 16, because on our more advanced problems on the variables on both sides, you're going to need to be able to compare those two numbers, 16 equals 16, or maybe on the more advanced ones, it'll actually be 16 equals 15, and then something's a little bit weird there, so we'll have to discuss that. All right, let's try our next one. Very similar to the level of example A. All right, so just like example A, our goal is to move the smallest variable. So we're going to look at the 2n, and we're going to move that to the other side. Our inverse operation, again, is we want to get rid of it, so we want to get to that neutral 0. So we're going to go ahead and subtract 2n on both sides. So if I subtract 2n on both sides, I'm going to have a 12 equals 3n subtract 9. Remember, good note-taking is realizing when you're not going to have enough room and maybe turning the page and taking care of that. So please be very careful with your note-taking. All right, so we're going to use our little skill just like what we did before. Remember, I don't want the 12 on this side, so just go ahead and put it on the right and then lightly cross it off, please. So again, put equals 12 on the right side and then lightly cross it off on the front. I don't have that step here. I have it switching sides. But again, it's a lot easier if you just put it on the right side and lightly cross it off on the left side, like I taught you last week. Question was, would it be wrong if you didn't switch it on the test? No, it's just we're trying to do best practices for the more advanced problems we're getting ready there. Yeah, some students actually just keep it like that, but they're not prepared for the stuff we're going to be doing later on in the year. Good question. All right, so again, two-step. Go ahead and solve those two-step equations. Inverse operations. Our goal is to find the value of n. So add n both sides, or sorry, add 9 both sides. After you divide, what is n equal to? Because when you divide by 3, n is definitely going to be 7. All right, if I were to check it really quick, I've got 2 times 7, and then add 12. And then the right side would be 5 times 7, subtract 9. Remember, use your parentheses when you're doing the 2 times 7 and then the 5 times 7. So you really have a 14 plus a 12. And then a 35 subtract a 9. All right, let's try C. This actually looks a little bit familiar to that triangle problem from yesterday. There's just more that you have to combine. So if you have your highlighter or if you have one of those bigger erasers or even a note card, my suggestion is to cover up the right side of the problem. So again, it's kind of like you would just place it over here, covering that right side. And again, the reason I suggest that is so you have less that you have to worry about within the moment. So if you cover up the right side, on the left side, you should do your box and circles like you've done before. So you'd put a box around the 5x and around the plus 2x. Or you can use a triangle or something like that. And then you do the same thing around the 3 and the negative 7, just different shapes from the x's. All right, so once you've simplified the left side, you're going to go ahead and do the same thing on the right side. So take your highlighter or your note card or whatever the case may be, cover up the left side, and then on the right side, you're going to do your boxes and circles. So box the 8x, box the negative x, which is really like subtract 1x. Circle the plus 1, and circle the minus 5. And then obviously do your adding or subtracting, and you should be good to go from there. Give you about 20 more seconds to finish your combining like terms. All right, so on the left side, what did you get? Tell your partner. It means actually talk with your partner. Tell them what you got on the left side. On the left side, you should have a 7x and then a subtract 4 or minus 4. Tell your partner what you got on the right side. Did you get another 7x? Because it's an 8x subtracted 1x. And then did you get another subtract 4? Yeah, so what we have here is a unique situation. This is considered one of the special problems. So we checked it. We did the whole correct boxing, circling, and things like that, even though it didn't show up on mine. But we have this scenario here where we have the same variable and the same integer. So let's just go ahead and show our quick step, and I want to get you to a certain point. Let's subtract 7x on both sides. Now, since the variables are exactly the same, you couldn't identify which one was smaller, so therefore easier to move. Again, they're the exact same thing. Or they are identical. Have you ever seen identical twins to the fact that you could not tell them apart at all? I've had students before, thankfully they were in separate classes, they were essentially the same person. Not really, you know. But they were identical. And what we have here is an identical or identity in our work. We have negative 4 equals a negative 4. And that was one of the benefits of talking about checking your answer last week, plugging it in, seeing if you can get it to the same numbers, because it was really leading you to this discussion. Meaning if you have it identical, it's called an identity. The identity tells us that our answer is all real numbers or infinitely many solutions. And what that means is, since we got it to an identical piece of information, the 7x subtract 4 equals 7x subtract 4, call it an identity, which means any value for x would work. So I can plug in a 1 for each of the x's right here, or even up here for all of these x's, do my 6th grade math, and it would come out to the exact same number. Maybe it comes out to 10 equals 10, or 3 equals 3. I can plug in a 0 for all of my x's. I can plug in a -5 for all of my x's. And it would work every single time, which means, again, it'd come out to the exact same number every single time. They are identical. Identity. So on your test, you might see either of these two answers presented to you. So make sure you know that it means the same thing. It means that we can use any x value and it will always work. The infinitely many solutions again, sorry, going back to that, just means you can keep coming up with more and more answers because you can keep coming up with more and more x's. You can use decimals, you can use fractions, you can use roots, things like that. All right, on example D, let's assume that it's already been simplified for us and we are at this statement here. So in other words, someone already did the boxes and circles combining like terms. So we now have this. So can we say, at least at this point, that this is an identical situation? No, because if you notice, it's a 3n plus 4 and a 3n plus 5. So although the variables are the same, the integers, meaning the 4 and the 5, those are not. So that means when I subtract my 3n on both sides, what happens to the n's? They disappear. So I'm now at this statement here, 4 equals 5. We talked about it last week. Talk with your partner if you remember what to do when you're comparing these two numbers. Again, talk with your partner what you're supposed to do when you're comparing these two numbers. So, does 4 equal 5? No. So what should I do? Cross off the equal sign. Since 4 does not equal 5, what's my answer? Have you heard of this phrase before? No solution? Which once again means there's no answer. There's no value for n that will make this statement true. Because I have to put the same number that I want to test at both ends. So if I wanted to test 1, it'd be 3 times 1. And on the other side, it'd still be 3 times 1. So there's no way that I get it. It might come out to like 8 equals 9, -5 equals -4, whatever the case is. But the numbers will never be the same in this situation, so our special answer is no solution. So it's either identical or close. I like saying that this is kind of like the good twin, bad twin mentality. So instead of identical twins, this is like the good twin or evil twin. Because again, it's not going to work. The 4 does not equal 5. No solution answer. No number will make this true. All right, we got a few more. Let's talk about our distributive property. That was not really on your quiz. It has been on our recent worksheets, but it will also definitely be on your test, many, many times, in fact. So our goal is it going to give us a special answer, or is it going to give us a normal answer of k equals a value? So there's nothing that I can do on the left side. 2k subtract 5, there's no like terms, nothing like that. So you should be on the right side using your distributive property. Remember those little arrows that we were practicing? So 3 times your 1. And 3 times your -2k. So you should now be at this point here. The left side is able to stay the same. The right side, we used our distributive property. If you notice, the variables are not the same, so it's not going to be a special answer. It's going to be a normal answer of k equals something. So it's back to example A and example B. The question is, which variable are we going to move? Which variable is smaller? Talk with your partner and decide which variable we should move. Now remember, the understanding of your number line is very key to help you determine which one is smaller, because we know on our number line, the smaller numbers are obviously to the left. So which one is smaller, the 2k or the negative 6k? Because we read that as subtract 6k, but it's really like negative 6k. So we're actually going to move the 6k by adding on both sides, because a negative 6 is smaller than a positive 2. And another reason we wanted to move the 6k is since I add it, it's going to give me a nice positive value for k, or k values. Where if I subtract 2k on both sides, students tend to make more mistakes dealing with those negatives. So I now have it to a beautiful two-step equation. Again, we've been getting a lot of practice on that. So go ahead and use your 2 steps to solve for k. Again, I think if we can get it to the 2-step, many of you are going to be very successful. All right, so what's the value of k? If we add 5 and divide, k is obviously equal to 1. And again, if you wanted to check it, you'd go up to the top, 2 times 1, and then you subtract a 5, and then the right side is order of operations. You work inside your parentheses, and so on. All right, double distributive property, essentially distributive property on both sides. If you wanted to cover up one side and concentrate on the other, some of you might be okay just going left to right. Be careful on the right side when you're distributing your negative 3. I've had students make mistakes on the very last arrow. Give about 10 more seconds and you should have it at least distributed. All right, so the left side you should have a negative 8x and subtract 2. On the right side, you should have a negative 3x. But what does the very last arrow give you? A positive 6. Make sure you have it a plus 6 there. That's one of the most common errors for 8th graders in solving equations. They forget the negative times the negative. All right, so decide with your partner which variable you want to move. Remember our discussion on the last problem. Remember, the question is, which one is the smallest, kind of like the lightest grocery bag? It's the easiest to move. So which one did you say, the negative 8 or negative 3? Negative 8 would be easier, so let's go ahead and add 8x to both sides. Again, we want to move the smallest or lightest item. All right, when you're doing this, we're being very careful with our signs still. So on the left side, the x's are gone. So I have a negative 2 equals. And then on the right side, my x's, I have a negative 3x plus an 8x. You can use your number line if you want to, Or you can even just think about it as 8x subtract 3x, which gives us a 5x. If you notice, the order is not exactly what I want, so let's use our little skill like we did last week. Let's take this and put it equal on the right. Again, just save you a little bit of writing. So instead of having to rewrite the whole thing like mine has up here, you just put it on the right and then lightly cross it off. All right, you got two-step equation. I'm going to give you a hint. Just like on your test, just like on this problem, it might come out to a fraction answer. So instead of an integer, like a positive 2, negative 2, it might come out to negative 2 over 3. So fraction answers will occur on your test. All right, what does negative 2 and negative 6 give us? Use our number line, the rule, negative 8. Because if you start at negative 2 and then you move left 6 spaces, you arrive at negative 8. And then if we divide, can I reduce that negative 8 over 5? No. So I'm going to keep it as a negative 8 over 5. So again, that's a small hint for what you're going to see on your test. You will have some fractional answers on your test. On your test, the multiple choice answers would be kept as a fraction. So there's no need to convert it to a decimal because you're just going to match up A, B, C, D. All right, two more, I believe. So if you notice, the left side is just distributive property. The right side is distributive property and combined like terms. So again, we're putting all those skills together from the past few weeks. If you notice, mostly everything is positive, so that's a little bit easier for us. So you just do your little arrows for your distributive property. And then on the right side, you're going to do your boxes and your circles. All right, so what's the left side going to give us? The left side, 2x plus 14. Beautiful. On the right side, we do our distributive property first, then we do boxes and circles. So my first arrow gives me a 6x, then a plus 6, and then I've got to subtract 4x there as well. So do your boxes, your circles. If you notice, your x's are going to combine. So what do I get for the right side x's if you do your boxes and your circles? So again, box 6x and box subtract 4x. Don't forget the sign. So how many x's does that give us? 2x again. So we notice something, right? We notice we have the same variables, but are they identical? No. So it's kind of like the good twin, bad twin mentality. They're very similar, but not identical. So if I were to subtract 2x on both sides, would I have the same value that I'm comparing? No, I have a 14 equals a 6, which is false. So you slash out the equal sign. And if you don't remember, flip back to find out which special answer that is. Look for the one that has the equal sign slashed out. So that would be a no solution answer. The no solution answer, again, means that there is no value for your x that will make this true ever. Because, again, you have x's on both sides. And if the x's are on both sides, then you'd have to substitute it in for each location. So, again, if the values are different like that, no solution means nothing would work. All right, last one. Just write it down and then pause for a moment, please. If you happen to have a pen, that'd be very helpful right now just for one little adjustment. So not a highlighter, but an actual pen, a different color than your pencil, please. Or a different color pen if you're taking notes in your pen. So when the problem is presented to you like this, a lot of students get confused on what they would actually be distributing, because they just see a 4 and then a subtraction sign. So what my suggestion is for my students is to write it like this. So put that little 1 there in front of the parenthesis sign. So you can just kind of squeeze it in. Again, you're using a different color to tell you, okay, that was something special. And we had a question just like this last week. Make sure you do not do your 4 subtract 1. We have to use our distributive property first, then we have to combine our like terms. So bring your 4 down, and then you're going to distribute your -1. So when you distribute your -1, what happens to the 3x? Becomes negative, right? Really the opposite sign. And then what happens to the 2? Really becomes the opposite, -2. So I now have 4, which stayed the same, subtract 3x, and then subtract 2. So finish up the left side for me, please. Do your boxes and circles on the left side. Some of you may have the right side covered up, so you're not having to worry about that just yet. So you have a 4 subtracted 2. Oh. So on the left side, you should have a -3x and a +2. No equal signs, though. Just have a -3x and then a +2. Then you have the equal sign. And then on the right side, you do your boxes and your circles. We're not moving the x's yet. I'm just combining my like terms. So on the right side, I circle my 7 and my subtract 3. So I now have this. So again, I did distributive property, combine like terms. Now it looks like example A and example B, just with more negatives, so we have to be very careful. So again, our discussion is, which variable do we want to move? We want to move the smallest one. Which one is smaller, -3x or -5x? We should move our -5x by using our inverse operation, and we're going to do that by adding 5x on both sides. So a -3x plus a 5x, you can use your number line, start at -3, go right 5, and it takes you to a 2. We now have a beautiful equation, 2-step to solve. All positives makes it a lot easier to find our value of x. Subtract 2. And then divide. So our value of x is going to be 1. So even though it would be complicated, you could always check this by taking the 1 and plug it in for your x's at the very beginning of the problem. Wonderful. All right, so we saw that we had normal answers like x equals, k equals, and so on. And then we had special answers. If the numbers were identical, it's called an identity, all real numbers, infinitely many solutions. If the values were different, like 4 equals 5, we slash out the equal sign, and our answer is a no solution. So we're practicing all the steps that we've been working on, our distributive property, our combined like terms, and our inverse operations. All right, thank you for being awesome. We'll get started on the homework.